So this video is going to show you how to make a pyroxene ternary plot. So you're going to go to the read the docs page, and then you're going to navigate down to Cpx and Cpx liquid, and then you can click on pyroxene classification diagrams. So you can have a quick look through what this notebook can do to see if you're interested in this, or for this example we are just going to download here, so press the NB viewer button. And then you're going to have a download button here on the right, so we can download that. We're then going to go back and you can see that the data we're going to use for an example is here on GitHub. So again, click the link, click download, and you'll have all of that. So now what you need to do is go into downloads on your computer. So you can see these two examples are here. So copy them and then put them wherever you want to work. So in this case, I'm going into my Google Drive and into my YouTube narration folder. So you paste this all in on however you use your file explorer on your computer. And then you're going to go to Jupyter Lab or whatever sort of Jupyter notebook thing you want to use. And kind of clicking on these, which is your file explorer, you're going to find the folder that you put these files in. So we're going to open up the notebook, and we are also going to open up the data just so you can have a look at it. So what we can see is that we have paired liquid and Cpx pairs in this example. Really doesn't matter if you don't have the liquid. All you need is your oxide contents of Cpx in any order with underscore Cpx after them. Make sure that you put iron as FeO total. That's how thermobar works. And then you can see this is kind of another set of data that we might have. So in this case, we're looking at pyroxene, but actually it would be the same for OPX. So this is just some instructions that you can read. This is going to import everything you need. If you have not installed thermobar already, you're going to need to make a new cell and go pip install thermobar and run that just one time on your computer. But I have thermobar installed, so I don't need to worry about this. So first, I'm going to run, so this is importing Matplotlib, which makes your plots, NumPy and pandas, which does some of your math, and thermobar, which is doing the work. Then we're using thermobar's import function, so this is pt import Excel. You're basically going to give it the name of the spreadsheet, so that's just here, and if you want you can just copy this across by rename like that if you wanted to. And we're specifying we're interested in the data in sheet 1. And this is a dictionary, so it holds a number of different mini spreadsheets. So to get all of your columns out, you can do my input, which is this. If you just want the liquid compositions, then it will look for only those phases with underscore liquid. You're not actually going to use this in this example. The key one you need is this Cpx's. So this is going to extract all of your Cpx data. So we can run this, and then we can look at what this looks like. So if we use Cpx's.head, it's going to print, and what it's done is it's pulled out all of those columns, it's reordered them, and you can just have a quick check through and check that all of the elements you're expecting are there. Okay, so the first thing we need to do is transform these Cpx compositions into the coordinates that we need to plot on a ternary diagram. So here we're saying Cpx comps term is pt.turnPoints pyroxenes, and then the sort of input argument is pyroxene comps, and you just specify whatever you called your Cpx's. So here I called them Cpx's with an X and an S. If you want to look what that looks like, you can see basically now it's just transformed it into sort of the plotting coordinates that you need for your ternary diagram. The next step is to make the ternary diagram, and then we're going to overlay the data onto it later. So there are lots and lots of options embedded in this plot pyroxene classification function. So the very simplest diagram will draw like this by default. You can specify your figure size here, so you can make it 6 by 4, or we can go back to the original, so that's the first thing. You can say, I don't want you to truncate the top, I want the relastanite end member. Okay, that's fine. You just specify the additional argument cut in half equals false, and now it will have the top. Okay, you might say, well, I want the field names on. Okay, that's fine. You just have to say labels is true, and then you can specify a font size for the labels. So here, this is font size 12. And you can also change the font size of these axes labels, so enter type ferrite, so like wollastonite. So we can run that. You can say, well, Penny, I want a grid on my data. Again, also fine. So you can just see this says major grid equals true. So you can basically just keep adding these optional arguments here. You can get a minor grid as well. I'm just going to move this over so you can see it. So again, there's just lots and lots of options you can look at. Okay, so let's say you've looked through these options and you decide that you don't want labels, but you want a major and a minor grid, and you want these labels to be size 12. So the first step is make the figure using the plot pyroxene classification function. That's the one we've been using all the way up here. Now you add your data. So if we remember, we called our transform data Cpx Comps turn. So what we're doing here is we're using the tx.scatter function. This is a Python function. So the first thing you specify is the data you want to plot, so those transformed coordinates. You're then going to specify the edge colour that you want. So in this case, I want a black edge on my triangles. Here, you're specifying the marker types. You could also put circles. You can look through all of the sort of Matplotlib marker types there. You're choosing a face colour, and you can choose a label and a size. So you can plot that. So you might want to say, okay, well, I want to colour, I don't want them all to be red because that's not really giving me any new information. And you can say you want to colour them by jadeite content. So we're doing sort of the same thing here. Now we are adding an additional line. So here we are calculating the Cpx components. This is your jadeite, your dioxide hedonbergite. And this is just simply the function pt calculate clinopyroxene compositions, which you feed in whatever you called your Cpx's. So here it's Cpx's. So again, we're using tx.scatter, giving those transformed coordinates in ternary space. But now we say we want to colour by the jadeite content. Here we want to set the minimum colour bar to the minimum observed jadeite content, the maximum colour bar to the maximum observed jadeite content. We want the symbol size to be 100, and here we're just specifying things such as the colour map. So if you're happy with this and you want to save the figure, you would simply uncomment this line, and you can see in a second you will now get a PNG file in your folder that has your figure in, and this has a transparent background, so you can sort of open this in whatever Illustrator program that you want. And you can add multiple of these TX scatters, so you could subsample them by sample name if you wanted to, or you could just add multiple different spreadsheets that you've loaded in.